Welcome back. We're taking a look at factorial notation and how to evaluate expressions that involve this. So the first thing you want to notice when you're asked to evaluate something that involves a factorial is that you do see an exclamation point. This is a very exciting math notation. It kind of makes me really happy. Now, the definition of a factorial just means that you multiply all of the integers or the whole numbers down from the number that you see all the way down to 1. So for example, if we're looking at 4 factorial in part A, we can think about it as written as 4 multiplied by 3 multiplied by 2 and multiplied by 1. So if we do the math on this, what do we have? 4 times 3 is 12, 12 times 2, and here, I'll do this, how do you say, by hand, just so that we see. We have 12 times 2 times 1, which is 24. So 4 factorial would be equal to 24. Now we could do the same thing. Let's take a look at 7 factorial. What does that mean if we were to write this out? This would be rewritten as 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you want to use your calculator to multiply it out, feel free. If we were doing this by hand, I know there's different ways to utilize the commutative property of multiplication. But I'll pull up a calculator just so that we can see. Let's share with you so you can see my home screen. And if we're just going to multiply 7 times 6 times 5 times 4 times 3 times 2 times 1, we end up getting 5,040. So I'll write that down. And then I will point out a very useful shortcut. So we have 5,040 is the value of 7 factorial. I would like to call your attention to if you do know previous values of factorials. So for example, we see 4 factorial as 4 times 3 times 2 times 1. So if we were going to look at 7 factorial, we do realize that we do see the same factors, 4 times 3 times 2 times 1. So an alternative way, another way, if we're looking at 7 factorial, you could start off by knocking off the higher factors, 7 times 6 times 5, but then realize that you are multiplying by 4 factorial if you already know the value of it. So we could, it does save us a little bit of time, 7 times 6 times 5. We already know that 4 factorial is 24. And then you could do the math on this. It takes a little less writing on the TI. So just in case you were wondering, 7 times 6 times 5 times 4 factorial, and 4 factorial was 24. And we do get the same answer. So one way to go. Kind of depends on, how fast you have your calculator out, or if your calculator is capable of all this. I know with the TI, it's not too bad to have to enter stuff into the calculator. So let's take this approach with 11 factorial. So if we're going to look at this one, 11 factorial, we could start off by saying 11 times 10 times 9 times 8. And I'd say times 7 times 6 times 5 times 4 times 3 times 2 times 1. But that, my friends, is really 7 factorial. So if we want to look at that, we realize that 7 factorial is the same thing as 5,040. So it does take a little bit of time off of your computations. So if we were to plug this into the TI, Let's go for it. There we go, share the screen. Again, it was 11 factorial. So 11 times 10 times 9 times 8. And if you want to look at the value of 7 factorial above, that was 5,040. So these numbers get pretty big, pretty fast. So let's copy that over. The value of 11 factorial would be, what is that, in the millions? So that's about 39 million. Let me see if I can share that over. There we go. And then I have to remember what I just entered on my TI. So I will check that really quick. We have 399,16800. So 399,16800. So what is that? 39,916,800. So this is kind of how the factorials work. I do encourage you to kind of get familiar with the notation of what it means when you do see the exclamation point at the end of a factor. Later math classes, we don't necessarily get to use our calculators, so understanding that all we're doing is multiplying the factors, the whole number factors, down from the number that we see and on to get the answer. That's helpful. But this is nice to help us out. Maybe we don't have our TI available, but you probably guessed it, that if our TI can do all these amazing things with summations, graphing, and etc., why wouldn't it have a factorial key? And in fact, you're wondering is correct. It does have a factorial key. So if you don't mind me showing you really quick how this is going to work, we'll look for this if we can. We're going to look at the probability. We do use this a lot in probability. So let me see. I think I wrote this down in your notes, but if I were to try to calculate 4 factorial, 7 factorial, and 11 factorial, a faster way to go is to use your math key. So let me see if I can switch back to your TI so you can see this. And if I wanted to call up the factorial symbol, first I'll press 4, and then I'll press the math key. And then you're going to use the right arrow key to go all the way over to the probability menu. And there you see it, item number 4, that factorial symbol. And if you press enter, we are getting 24. Same thing we got earlier. If you want to look at the next factorial, I believe it was 7 factorial, same idea. 7, press the math menu, scroll over, probability, item number 4, and 11 factorial. So you can kind of see, oops, I don't want to press second, I just want to press math. There we go. Scroll over to the probability menu one more time, item number 4. Let me see if this will let me press it. Sorry, my other window got in the way. Let's try this again. You won't have this problem because you're holding your calculator. And notice we end up seeing that we're actually getting all the numbers we had if we were to copy by hand. So I just kind of like to point that out to you. If you were interested, if all you have to do is find the value of a factorial, there's no real need to have to do it by hand unless that's something that you're trying to develop on your own. But you can see if I move this close by, we can see that we are still getting the same answers. So I hope this helps. I do encourage you again, just remember what it means to be a factorial. We end up seeing this a lot later and we use this more in an algebraic form. But for the purposes of this course, feel free to use either method and you should be fine. I hope this helps. I will see you in the next example.